Hello everyone, welcome back to online lecture series on fluid mechanics and hydraulic machines. We are continuing our topic of discharge through we are continuing our topic of dynamics of fluid flow, in which in our previous lecture we have studied about discharge through fully submerged orifice. So let's have some revision of these topics. So first we studied about flow through large orifice, in which we took this small section and we integrated the discharge through elementary strip over the height h1 to h2, and the flow rate that we obtained was 2/3 of CD B into square root of 2g h2 raised to 3 by 2 minus h1 raised to 3 by 2. The next was discharge through fully submerged orifice. So here, as you can see, that the outlet of orifice is fully submerged already in the liquid. So in this case we obtained the mass flow rate of Q as CD into B into H2 minus H1 square root of 2GH. And the last theory that we discussed in our previous lecture was discharge through partially submerged orifice. So as you can see that the outlet of orifice is partially submerged on the downstream side. So here we are going to take 2 points. Point 1 will be over here and point 2 will be on the downstream side. So let's copy this figure to continue this theory. So here if you see, there are two portions that we need to focus here. If you see on this side, the inside the water, this can be considered as fully submerged orifice. So this is fully submerged case, and above it we will have here as free. Okay, so we can calculate the mass flow rate by combination of these two. So for submerged portion we can write down the equation as Q1 is equal to CD into B into H2 minus H into square root of 2GH. That is the first one. And for the free portion, Q2 can be written as two-thirds of CD into B into square root of 2G H raised to 3 by 2 minus H1 raised to 3 by 2. So here the final answer will be Q is equal to Q1 plus Q2. So here we can complete this theory as this is equal to the first discharge plus the second discharge in this way. So this is the end of this theory. Let's copy this work. Over here. So we are done with this theory. Now let's move forward with our next topic. Our next theory is notch and wear. First we will define notch. So similar to our previous devices, it is used it is a device used for measurement of fluid flow rate. Through a small channel or tank. Next is wear. It is concrete or masonry construction placed in an open channel over which the flow occurs. So here are the notch and wear, and one theory that I'm giving you as a part of self-study. So let me write down the name of that theory. Classification of notch and wear. So this will be a part of self-study for you. So now let's move forward to our next theory. Discharge over rectangular notch or wear. So here the water will be flowing above this. in this way. So here there are few terms that we need to understand. So here this will be, first part is this will be the height, h, this portion is known as nappe, and this portion is known as crest or sill. So this figure is for a rectangular notch, and now we will be drawing the section at crest. And this will be at height h, and this thickness will be bh. And now we will be drawing the same for the wear. So here wear is not that different, it is same as this, like this. So this is for rectangular wear. As far as nomenclature is concerned, let's say that h head of water over the crest and L is the length of notch or weir. Okay, so here we have considered a small strip as we can see in this figure. So let's first calculate the area of strip. Okay, so first we will copy this part into our main slide. So this is from continuing from here, the area of the strip is equal to, as it is evident from this figure, is L into dH. Now the next is a theoretical velocity of water flowing through strip is equal to square root of 2gh. So the next is the discharge. Discharge dq is equal to cd into LDH into square root of 2gh. So finally we need to integrate this to get the total discharge. So Q is equal to integration 0 to h dq is equal to integration 0 to h cd into L dh square root of 2gh. So we will take constant terms outside. then we will have CD into L into square root of 2g integration 0 to h square root of h into dh. So here instead of square root of h, we can write down h raised to 1 by 2. So after integration we will get CD into L into square root of 2g into h raised to 3 by 2 0 to h divided by 3 by 2 is equal to 2 by 3 CD into L into square root of 2g into h raised to 3 by 2 minus 0 raised to 3 by 2. So finally we will be getting this as 2/3 of CD into L into square root of 2g into h raised to 3 by 2. So this will be the value of total discharge Q. So let's copy this work into our main slides. So with this we have completed this theory, and here we are also not going to start any new topic. Just a gentle reminder here that I have given you this part as a self-study. So that also I am mentioning over here, that is, this part is for self-study. Now our next topic is discharge over triangular notch and this we are going to discuss in our next lecture. Okay, so this is end of today's lecture. Thank you for watching this video.